Hey everyone, and welcome back to The Explainer. Today we are diving into an incredibly powerful piece of software called tunnix. If you've ever found yourself just completely frustrated trying to get work done in a highly restrictive network environment, you're definitely going to want to pay close attention to this one. We're going to explore the ingenious way tunnix operates, and more importantly, we're going to unpack the massive, total game changer that is the newly dropped v0.3.0 update. Okay, let's dive into this. Here is our quick roadmap for today. We'll start with the firewall problem, look at the v0.3.0 paradigm shift, take a peek under the hood, discuss the security risks and caveats, and wrap it all up with why this matters. Kicking things off with Section 1, the firewall problem. We all know that developer friction. So, have you ever been stuck behind a firewall that literally only allows plain HTTP traffic? You know the exact scenario. You're working in a Cloud Shell environment, maybe GitHub Codespaces, Gitpod, or maybe you're just trapped behind some draconian corporate reverse proxy. Now, these environments happily serve up standard web pages all day long, but they strictly block direct TCP connections. They might even actively strip or mangle your WebSocket upgrade headers, which leaves you completely locked out of standard tunneling tools. Honestly, it's incredibly frustrating.
Well, enter tunnix. Tunnix is an encrypted SOCKS 5 and HTTP proxy tunnel, but here's the kicker. It operates entirely over plain HTTP and server-sent events, or SSE for short. Because it relies purely on standard HTTP requests, specifically, a series of POST requests for sending your data and a simple GET request for the SSE stream, it just slips right through those lockdown environments. Things like Cloud Shell and strict proxies just see standard web traffic and they let it pass right through without a second thought. The official tagline for the project honestly says it all, and it's got a bit of dramatic, cinematic truth to it. When HTTP is all you've got. It really is the ultimate fallback, your ultimate lifeline when nothing else works.
Now, for those of you who might be new to tunnix, let's just do a super quick review of the baseline features. You can think of tunnix like a hidden, secure tunnel safely nestled right beneath a really busy, heavily monitored highway. It handles both SOCKS 5 and HTTP proxy traffic on just a single local port. And it does this by cleverly auto-detecting the protocol with basically zero performance cost. It literally just peaks at the very first byte of the connection. If it sees a 0x05, it routes it as SOCKS 5. If it sees an ASCII letter, boom, it routes it as HTTP. The entire tunnel is end-to-end encrypted with SHA-20 Poly 1305. And again, it uses that highly reliable HTTP/SSE transport, completely bypassing any need for WebSockets.
Which brings us to Section 2, the v0.3.0 paradigm shift. This is a massive evolution.
Up until now, tunnix has been a really incredible proxy. But with v0.3.0, tunnix is no longer just moving packets around, it is actually executing commands. Honestly, this is practically a magic trick. Tunnix has transformed from a simple silent tunnel into a full-blown remote control powerhouse. And this brilliantly illustrates just the sheer scope of this release. The absolute star of the show here is the brand new tunnix remote-exec CLI subcommand. This lets you open interactive remote sessions, like a bash shell or running top, directly over your existing HTTP tunnel. But we also get vital additions like opt-in service security, deep Unix-only PTY integration, completely new protocol extensions, and some really critical fixes to tunnel synchronization. It is just a massive amount of new value packed into a single binary.
Moving on to Section 3, under the hood. Let's break down how this remote execution magic actually works.
Now, what's really interesting about this slide is the architectural flow. You can see the local client establishing that standard SSE stream right to the server. But now, we have this green arrow representing a dedicated PTY session tucked inside the tunnel. When you run remote-exec, the client actually forces your local terminal into raw mode to capture your direct keystrokes, like if you hit Ctrl-C. The server receives those keystrokes, provisions a pseudo-terminal using the portable.pti library, and then it streams the output asynchronously right back to you.
To actually make this whole terminal flow possible, the devs had to extend the core communication protocol. They added 3 new message types. First up is X, which tells the server to open the PTY, passing along your terminal dimensions and the command. Next is resize. So if you physically resize your terminal window on your local machine, tunnix captures that sig winch event and fires off a resize message so the remote server dynamically adjusts to match it. And finally, exit status cleanly relays the remote child process's final exit code right back to your local client.
Also under the hood, v0.3.0 completely hardened the underlying tunnel synchronization.
Previously, there was this sneaky little race condition where a client might fire a post request with data before the server had fully registered the SSE stream session. Well, now, the startup sequence explicitly blocks. It waits patiently until the very first valid SSE frame arrives. This guarantees the connection is completely locked in and synced up before any sensitive connection data is ever transmitted.
All right, Section 4, Security Risks and Caveats, because any great tool comes with trade-offs we need to respect.
First and absolutely foremost, remote-exec requires the server to be run with the -allow-exec flag. And make no mistake, folks, this is literal God mode. If you enable this flag, anyone holding the server password has absolute remote code execution on that box. By default, this is strictly turned off, and the server actively rejects any execution requests. If you do turn it on, the server prints a very loud warning. You really must fully understand the implications of granting a shell to authenticated users on your host.
So the crucial point here is understanding exactly what this new feature is actually built for. Remote-exec is absolutely incredible for interactive, human-driven tasks, getting a bash shell, running top, or jumping into Vim over HTTP. It's magical. However, it is fundamentally terrible and frankly unsafe for transferring raw binary data. If you need to pipe a binary file, you should definitely be using standard tunnix TCP tunneling, not the remote-exec command.
And the reason for that limitation is what we can call the canonical PTY catch. Because tunnix provisions a PTY that's left in its default, line-buffered canonical mode, which it kind of has to do to handle things like window resizes and Control-C, it actually alters raw bytes. For example, the PTY terminal driver will not signal an end of file unless it sees a line terminator. So if you try to pipe data into remote-x that doesn't end in a new line, the tunnix client actually has to synthesize and inject a trailing new line character before sending the EOF signal, just to flush the buffer. That means the output the remote process sees is not byte identical to what you sent. It drops byte fidelity in exchange for perfect interactive terminal behavior.
Finally, Section 5, why this matters. Let's look at the big picture.
Let's move to tunnix and see how this builds a completely interconnected ecosystem. What started out as just a clever hack to get a proxy through Cloud Shell has really matured. Tunnix v0.3.0 weaves together the new CLI subcommand, the opt-in God mode security, the intelligent protocol extensions, and deep Unix PTY integration all into a single cohesive workflow. You no longer have to choose between having a proxy or having a shell in restricted environments because Tunnix now elegantly provides both over the exact same encrypted HTTP stream.
Which really just leaves us with a fascinating question to ponder as we wrap up. As corporate and cloud network firewalls continue to get tighter and tighter every single day, how will tools like tunnix continue to evolve and blur the line between simple traffic proxying and total interactive remote control? It is an incredible space to watch, and I highly encourage you to go explore the source material and see how these features are implemented for yourself. Thanks so much for joining me for this explainer, and keep learning.